will continue in flow line, that is the vector field, and vector field flow line in parametric vector, and that is considered as kind of a future in calculus scenario, because it has calculus, it has algebra, and it has vector. So everything is there. Now, if we see the kind of a vector field, as we discussed, that vector field is a function over over x comma y. If I have a plane, xy plane, and if I have points x comma y, there are several points, then at each point, if I kind of take any point x comma y, then if I go for algebraic equation where fxy is a function over x comma y, if this is xy plane, in the xy plane, if I pick any x comma y, any point that is x comma y, and if I go function over x comma y, and if I place the value of x comma y, means x is 2 and y is 3, in the algebraic equation that is dependent upon independent variable x comma y, it would result in a value. So fxy, where f is small, fxy would result in a value where x and y, two independent components, we would push in the algebraic equation. If that is the case, then the value can be the z-axis value, the vertical component, or value can be the density in the xy plane. This is as far as algebra is concerned that we saw. Now, if I have fxy where f is capital and it's a vector, so on top of it we have array. So if it is capital fxy, then for any point x comma y, if I place x comma y any point, it would result in a vector. So it's a vector factory. If it is a vector factory, then if I have 20,000 xy points, then 20,000 it will result in vector. 20,000 vectors that it would generate. So it's a vector factory, that is called vector field. We saw, and relationship between algebraic equation and vector field. If we see the vector field nomenclature, its grammar, its architecture, then capital fxy equal to f1i plus f2i plus f3i whatsoever. So it has various components. F1 is one component along I-axis, F1i, F2j, F3k, and so on. So ith component along x-axis is F1. So F1 is a function over x and y. If f is a function over x and y, then F1 is also function over x and y. This haunts the mathematics kind of mathematics programmer or a person who is dealing with mathematics. That fxy is a function over x and y, then its component f1 and f2. F1 in I direction and f2 in j direction. Still f1 is also a function over x and y, and f2 is also a function over x and y. Since it is a vector field, so it is I and j. Now, if I change x and y repeatedly, then different set of I and j, f1i plus f2j, where f1 becomes a value and then f1i and f2 becomes a value, then f2j, so it will kind of generate different kind of vectors. So this is what we are seeing. So from algebraic equation, if we want vector field, then we have to differentiate along x-axis, y-axis, z-axis, and that we get the f1, f2, f3, and if we stick together f1, f2, f3, then it leads to fxy, capital, all in capital. Okay, where in algebraic equation it is small fxy. Here capital F and on top of it there is a vector. So fxy, f1 xyi plus f2 xyi, these are the components. Now the most kind of interesting thing is that if this is a, consider this is a velocity vector, like if I have a water stream that is flowing and I have one piece of paper, piece of plastic, then it will float certainly. Piece of plastic, and that is flowing along the water, but it is sometime it is taking this side, sometime taking this side, sometime taking this side. So at each point I have, so if I consider the velocity of the plastic, so if I have equation of the vector field as a velocity field, then I can address the plastic as a velocity. Now, velocity along with the vector, that is lacking in general velocity. If I say that I have an algebraic equation of velocity, then at each point what is the velocity, that we can consider, that is the one. If I have algebraic equation of velocity, then at each point what is the velocity, that we can calculate. Now other thing is that if I integrate that equation, then at each point how far we are from the origin. If I have started kind of any vehicle, or we start walking, that is a velocity vector from 0, then if I integrate, then at each moment we are at how far distance from the or 0, that we can get if I integrate the velocity vector. That is called flow line also. Here, not only we have velocity point at each time, we have vector also, that in which direction the person was at that time. Certainly, it makes sense if I have kind of something that is taking turn when it is in velocity. Okay, so like a motorbike, if it is a kind of in velocity, but sometime it is in this direction, this direction, this direction, this direction, and in addition to their position, we are also interested in their direction because it makes sense. Okay, their direction sometimes it makes sense. Like if you are flowing in a water, then your direction matters. Okay, so if there is a boat, and this is boat is in exactly same direction of water is flowing, because water has the velocity mainly, so then its velocity will be more. But if boat is like this, sometimes it is going like this, then the velocity that is imparted on the boat through the water will be lessened if it is not along the water. So that matters. Here it matters. So now if I have a velocity vector, and if I know at each point boat is in what direction and where, then we can calculate the displacement vector, because displacement will be not as the velocity of the water. Miss, please mind it. So if water has velocity of kind of 10 kilometer per hour, and if boat is going, if I put the boats, then not required that boat will move in 10 kilometer per hour. If boat is dancing, sometimes this direction, sometimes this direction, sometimes this direction, rather than going like this, it is going like this, then certainly totally it will not gain 10 kilometer per hour. Then what would be the condition? So condition is at what point, what is the direction of the boat, means what is the vector of the boat. So there it comes as velocity field. Velocity field means what at each point, what is the vector of the boat. So that is called velocity vector. If that is true, then we can calculate the flow line, that in what direction it moved, and so that at each time how far it was from the beginning. Certainly it will not be 10 kilometer per hour. So this is considered as better future than algebraic equation, that is algebraic vector. So rather than calling it parametric vector, we can call it algebraic vector. So that is the situation. Now if I have velocity vector and I have f1 component and f2 component of the velocity vector, then can I bring the flow line? So flow line, Now consider that fxy, where f is capital and it is velocity vector, x comma y is independent component over it, f is there, and then f1 component, f2 component. So if I say fxy equal to, so xy I can consider as xt, yt as far as parametric equation is concerned. So algebraic equation, vector field, and then parametric equation. So from algebraic equation we can get vector field, this we have discussed it, and from vector field we can get the parametric equation. So if I say vector field is fxy, I can say it is fxtyt. If it is xtyt, then xtyt are two components in the parametric vector where xt is dependent variable on t and yt is dependent a variable on t. This is the architecture and grammar of the parametric equation. So I can say f, where f is a vector function or vector field over xtyt. If that is the case, then f1 is also function over xtyt and f2 is also a function over xtyt. Let's proceed. So suppose so I can say now f xtyt, instead of xtyt I can say rt. So rt is a parameterized vector. So f rt equal to f1 xtyt, f2 xtyt. Okay, so that is the situation. Now FRT is a kind of differentiated form of the algebraic equation. Then whatever the parametric value we want to get, that is the should be the integrated over the FRT. So I can say R and then kind of single quote, that is derivative notation, R on top right single quote t or dr by dt. So dr by dt equal to f rt, capital F, on top of it one arrow and in the braces rt. So dr by dt equal to f rt. If that is true, then the dr by dt, so r has component as x, t and yt. So dx by dt is one component and dy by dt is another component of parametric vector. So dx by dt equal to f1. If f equal to f1i plus f2j, and and then f is a function over rt, then if frt equal to differentiated form of rt, so dr by dt equal to frt, then dr by dt equal to f1i plus f2i. If dr is xti plus ytj, then dx by dt equal to f1 and dy by dt equal to f2. If that is the case, then xt, that is the kind of the x component of the parameterized vector, is integration of f1 over t. Okay, and y dx by dt equal to f1, dy by dt equal to ft, where x dx by dt, where x is the x component of the parametric vector. So parametric vector is a flow line that we are trying to calculate. Dy by dt equal to f2, where y is the yth component of the flow line or parametric equation. Now, now consider that I have equation capital F fxy equal to I plus xj, I plus xj. Then dx by dt equal to 1. Okay. If I consider the vector field as a differentiated form of a flow line, vector field as a differentiated form of a parametric equation, vector field as a differentiated form of algebraic equation, I can get back the flow line by integrating the vector field. How we can get the flow line has x component, y component. X component is function over t, y component is function over t. That is the parametric vector. And here in the vector field, we have component as f1 and f2, where f1 is function over x and y, and f2 is function over x and y. Now, if I have equation f equal to I plus xj, then the ith, the first component, that is f1, is 1. Now, since I plus xj is differentiated form of the parametric equation, and so parametric equation is RT, then dr by dt equal to I plus xj. This is the what we are considering. If dr by dt, r I can substitute as xi plus yj or xti plus ytj. So xti x dxt dxt by dti plus dyt by dtj equal to f1i plus f2j, where f1i plus f2j are kind of disintegrated form of f x comma y. If that is true, then dxt by dt equal to f1, dyt by dt equal to f2. If that is the case, then xt of the parametric equation or flow line we can compute as integrating in while integrating the f1 with dt, and yt component I can get by integrating the f2 by dt. Okay, if that is the case, then xt equal to t, because f1 is 1, the f equation is I plus xj. I plus xj, if it is a kind of a velocity vector, then at each point, okay, then we can say the vector is I plus xj. So the vector has a direction, that is I plus xj. If x is becoming larger, 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 then its y-axis component is growing. So if this is x-axis, this is the way water is moving, then at the beginning I plus xj. So x is 0. Okay, so it will be in this direction, but as we move, then xj, as x is growing, the j component is growing, so both is slowly it is taking this vector. Okay, I believe it is understood. So a boat is flowing on a water river stream is going on, and a boat is flowing like this, but boat is slowly, as it is moving, it is taking this turn because the jth component is growing I plus xj the way x is growing. But if I move, okay, if water stream is in y direction, then it is not growing because x is not growing, whatever. So that is the boat is rotating as it is moving in x direction. So now if I try to get the flow line means the distance at any time. So or the parametric vector. So xt equal to f1 dt integration. So f1 is 1, the integration is t. If t, so it will be t plus some constant. That is the equation of integration. So t plus some constant. That constant, now this has become the x component of the parametric vector. X component of the parametric vector, if we see, then it is the vector and the point through which vector is passing through. If we remember, the parametric vector has two vectors. One vector is a vector of a point through which the vector is passing through. Another is actual the position vector. So if it is a t plus constant, then constant is the point through which it is passing through. So if I know that the boat is passing through a certain point, that point's x value we can keep here. So so suppose it is x0 only, x0, y0. So it is t plus x0. Now we have actual equation f equal to I plus xj. Now x component of the parametric vector is t plus x0. Now the y component I have to integrate x with dt. The x what we receive t plus x0 that we have to place. So t plus x0 if I integrate, then it will become t square by 2 plus x0 t plus y0. Now the x component of the parametric vector is t plus x0, whereas the y component of the parametric of flow line is t square by 2 tx0 plus y0. Now y0 here is the point through which this flow line is passing through. Okay, so that is the concept of calculating the flow line or distance vector from the vector field. Now consider that if I have a vector field as constant 3i plus 4j, then 3 will become 3t, 3t plus x0, and 4 will become 4t plus y0. So that will be the parametric vector or flow line. If it is, suppose it is minus xi plus, if it is a kind of minus yi plus xj, okay, so if it is minus xi plus xj opposite, then we can think, no, it is not, normally it cannot come. Now xt in the parametric vector is minus y dt. So we will run to calculate the y first, and then y is x dt integration. So both are coupled with each other. So we can think something like sine and cos, because sine integration is cos and cos integration is sine. So that way we can bring in the flow line, but we are not always lucky. So then we come to Euler's estimation. So getting the flow line from the vector field is not straightforward. If any of them is a scalar like f equal to I plus xj, where I component is a scalar, then we can get the x component and then we can replace other places and we can get the other value. Otherwise, if both are in xy form, then it is almost impossible to get the flow line. In that case, we will go with the Euler representation. More on it, that we will see that like if how like gradient vector. Gradient vector is another example of vector field. So more we'll see in the vector field, because vector field is going to become future in calculus, because not only we have point, we have direction also. That much is not possible through algebra. So vector field, that we will see.